All right, 2.1, let's go over some of the problems that people had questions on. First of all, they said 1 through 9, and it said the inequality -1 less than x less than 3 can be written in interval notation. That would be from not including -1 up to 3, close parenthesis, not brackets because it's not equals. Okay, that's 1. Number 2 said x equal -2. If x equals -2, the value expression 3x squared minus 5x plus 1 over x. Putting in -2, you'd get 4 times 3, 12, because you have to square before you take times that. So if we're putting in -2, squared is 4 times 3 is 12. -5 times -2 is plus 10. And 1 divided by -2 is -1/2. And so we get 22 minus 1/2, 21 1/2, or 21.5. And 3, the domain of this, x minus 3 over x plus 4, is, it would be everything except, all reals except x equal -4, because -4 would cause division by 0. You could also write it -infinity to -4, or -4 to infinity, but not equal to 4 in either one of those. That's the same as this or that. Number 4, solve the inequality 3 minus 2x greater than 5. You subtract 3 from both sides, and then divide by -2. And since you're dividing by a negative, you have to flip the sign, and so the answer, the solutions to this, are numbers that are less than -1. Rationalize the denominator, 5. If you have 3 over the square root of 5 minus 2, you have to multiply this. The square root of 5 has got plus or minus something, so you use the conjugate. And the conjugate of this expression is the square root of 5 plus 2 would work. So you get in the numerator 3 square root of 5 plus 6, and in the denominator you would get square root of 5 times square root of 5, which is 25, which is square root of 25, or 5. Then you'd have plus 2 square roots of 5, minus 2 square roots of 5. Those would cancel. Then you'd have -2 plus 2, -2 times plus 2, which is -4. And 5 minus 4 is 1. So the answer to this would be 3 square roots of 5 plus 6 divided by 1, or just that. 6 says the quotient is considered rationalized if the denominator contains no, so a quotient's the answer to a division problem, and if the denominator, which is the bottom part of this fraction, has no square roots or cube roots or any kind of radical in it, then it's considered rationalized. So no radicals in the denominator. That's what they wanted you to get to. Okay, now we got 8. 8's out of that section, so we're going to see some other kinds of questions here. 8 says, if the domain of f is all real numbers on the interval 0 to 7, including 0 and 7, and the domain of G, this is for f, and for domain of G, domain of f, domain of G is from -2 to 5, including -2 and 5. Then the domain of f plus G, then it would have to be something that we could put into both f and G. What can go into both of these? Well, -2 up to 0 can't, but 0 can. 0's in both of these. Up to 5 is, but beyond 5 works here, but not there. So the domain of that would have to be from 0 to 5, because you have to be able to put them into both functions. That's what they want you to understand from that. 9. So the domain of f divided by g, the domain, let's make this clear. I'm using a capital letter for the domain, capital D, and then f divided by g, a subscript, a smaller subscript to say the domain of what. Domain of f consists of all numbers x which give g of x is, and so if we're going to have the function is f of x over g of x, then the domain of this would be everything that works for g except what causes g to be 0. So they want you to say g of x cannot equal 0. The domain for which x is not equal to 0, and the domain for both, and the numbers also have to be able to go into f and to g. So they have to, the domain is numbers that you can use in both except the one that might cause 0 for g. So the domain of f and domain of g. That's what they wanted you to put in there. This in the first blank, this for the other two blanks. Okay, those were 1 through 9. Then we skip clear to 17. And 17 said the expression f of x plus h minus f of x over h is called the difference quotient. Because we're subtracting here in the denominator what is x plus h minus x. We're finding the slope. So we're doing the differences and we're dividing, and when you divide, the answer is a quotient. So we call it the difference quotient. So this, if I ever say on a test, find the difference quotient, you're going to do this process. And I have some problems on that for you to do. And then finally 18. Oops, excuse me. Yeah, 18. 18 says if y equals f of x, so y is what you get out of the function, is said to be defined explicitly. Y is whatever you get out of f of x. All right, now we'll go to the next.